Okay, so today we're talking about polynomials. That is a polynomial. Okay, a polynomial, when you graph them, poly means many. Okay, polynomial, many nomials. I don't even know what a nomial is, but I can tell you that it's got a lot of terms. A lot of times these things look like this. 4x to the fourth plus 3x cubed plus 2x plus 1. Okay, so let's just talk about these functions for a second. Do you remember that the y-intercept is where x equals 0? I've said that to you before. I'm going to say it again many times this semester. The y-intercept is where x is 0. If I stick in x is 0, all of these would cancel. Do you get that? So the y-intercept on this is just the last number. It's not always going to be the last number, but it's always going to be where, when I stick in 0, that's what the y-intercept is where x is 0. Okay, so here's the y-intercept. Could this equation possibly be right for that graph? No, because the y-intercept here is about 160. Or no, look at my units. It's like 50 for each box, so it's 200. No, that doesn't make sense. It's got to be 25 for each box. Sorry. So it's 175. There we go. That's 175. So do you get how I'd have to have a 175 at the end? All right, next thing. Do you get that this thing has a high spot and a low spot in it? We have a special name for that. Know what low spots are called? Trough is a good word. Minimum is the one I'm looking for, though. But you're right. It is the trough, especially in a wave. If you're like a sailor, you'd probably call it that. And then what's the top, the high spot called? A maximum. So those are minimum and maximum. Now, I want to have you put one in your calculator right now that I know will create a minimum and a maximum. Please type that one in right there. Okay, so on your calculator, y minus 2 and x plus 3, only the x plus 3 is being squared here. All right, x minus 2 and the x plus 3 quantity squared. All right, so now if I graph this thing, hit graph, if yours doesn't look like that, it's because your zoom is different than mine. But if I do it, I zoomed out a little bit to be able to see the high spot and low spot. All right, now there is a neato way to find the highest and the lowest spot. And you got to tell your calculator where you want to find the highest and lowest spot, because there might be 3 high spots in the graph or 3 low spots. All right, so here's how you do it. You go second, calculate. And what do you think a high spot is called again? Maximum. Let's do that one. So number 4. Now, it's now asking me for a left boundary, as in go to the left of the high spot that you want to talk about, because there might be multiple high spots. So I'm moving the little spider to the left of the mountain. Okay? I'm to the left of it. Then I hit enter. Then it wants the right boundary. Did you notice that little triangle that just came in on your graphing calculator? It's telling you from here to, and now it wants the other side. So I'm going to go to the other side of the mountain, just to the right of my maximum, and I hit enter. Now it brings in the other triangle and it says between here and here, and then it says guess. That means it wants me to get really close and then hit enter one more time. There we go. Maximum is negative 3.000003. Isn't that kind of weird? Shouldn't it just be negative 3? Well, kind of. Your calculator at this point is rounding what it sees on the screen. That's the way I'm thinking of it. It's not as exact because it's trying to read its own graph. Now, I know yours might be slightly different. But just think about it for a second. If yours is negative 3.000087, isn't that pretty dang close to this? Yours might be off slightly than mine. And that 2 calculators side by side will be different. Okay, so somebody else tell me what yours says. Negative 3. Okay, negative 2.99999. That's just a teeny tiny bit less than negative 3, right? So, and then look at the other one. This, think about it. Do you know what this e to the whatever means? That means move the decimal 11 spots to the left. Yours could be 12 spots to the left or 10 spots to the left. But either way, if I move the decimal like 10 spots to the left, don't you get that that pretty much rounds to 0? If I have 0.0000000031, isn't that pretty much 0? All right, so again, I bet you that there's not many calculators that are the same. Okay, because your calculator is kind of doing a rough estimation of what's on the screen for it. And I know you're not used to that. You're used to thinking calculator, if my calculator and her calculator get a different answer, one of them's wrong. Nope. When it's reading these graphs, it'll be close. The close is good enough because for Pete's sakes, this is going to the like 100 billionth place. Okay, and it's 0, 0. If you're going that many zeros, if you haven't figured out by now that that's going to round to 0, no matter how it ends. See what I mean? All right. So back to this. If I now am looking at these two numbers, which do you think? They're really close to each other. One's 3, one's 3.14. But which do you think I want, the x or the y? Well, this is a maximum, which implies like highest point. So the y is what we want, because y controls how high you go. You get that? So we wanted the y of it to tell the maximum. So the highest it goes in that area is negative 3. Oh wait, no, that was the 0 one, wasn't it? Because this negative 3.14 blah blah blah, that actually rounds to 0. So the highest it ever goes is 0. And just look at the big picture on the graph. You see how this is the 0 line, right? It's pretty much touching 0. So the highest it goes is 0. All right. Now let's talk about mins and maxes from the minimum perspective. You see the little low spot there? Everybody just use your big brain and go to the same neighborhood where I was before, second calculate, and see if you can view that one yourself. I realized something the other day. In a way, this class is a privilege to teach because for many of you, this might be the hardest math class that you will ever take. Process that for a second. Not all of you. If you're going to go on to calc, I'll be harder than this, but not tons harder. I've had a lot of kids tell me that they took pre-calc, and that was one of their harder classes they ever took, including harder than calc for them. I've had a lot of kids say that. So it's a hard class. Okay. So, but you could definitely argue calc could be harder. But there's a lot of you that won't take calc. You'll get done with this class and you'll say, you know what, I don't think I need to have that calc because I'm going to be a whatever major. And so for a lot of people, this will be it. This will be the highest one they take. They may take something for math next year, but it won't be higher than this. And that also is kind of weird to people. It's like, what? How can you take a math class that's not higher than this one? Because there's from here, you can branch out and study different things. Like if you take stats, it's not higher than this class. This is actually way higher than stats classes. Higher level math. Stats is kind of complicated, but it's actually not complicated math. It's like averages and, you know, it's not that complicated. Okay, stats is still a challenging class, but it's not as high a level. All right, anyway, the point is that for many of you, this will be the highest class that you take. And some of you will say, I'm going to take calc, I'm just going to take it either in high school or maybe I'll wait to take it in college. So I'm only probably talking to like 1/3 of you, but I'd say 1/3 of you, this is the hardest math class you'll ever take. So I'll do my best to help you understand it. All right, so now I hope you did this. Second, calculate the minimum, which is number 3. And then I go to left side of it. I get down here, be to the left of it. I don't have to be super close. I just be generally on the left. Then I go generally to the right. I'm on the right of it now. And then it says guess, and that means get close. So I'm really close to the minimum there. And now, remember, you got an X, you got a Y. Which one do I care about? The X or the Y? The Y. And so the final answer is about negative 18.5. Raise your hand if you had that. Good. Okay. So, next thing I want to talk about. Can there be two minimums on a graph? Yes, there can. Because they're local minimums. Like around this neighborhood, do you get that that's the lowest spot around that neighborhood? And this is the lowest spot around that neighborhood. It's like in your neighborhood, you don't want to be the house that's the lowest. You know why? Flood. Because when you get a lot of water, like tons of rain, it all runs from your neighbor's yards all into your yard and then into your basement, and then it floods your basement. Okay? So you should never buy the lowest house in the neighborhood unless it's not in a rainy area. Okay? Highest spot usually doesn't have that trouble at all. Okay? But the lowest spot, that's a dangerous thing about being the lowest spot. You can overcome it with some things like buy certain kinds of pumps that you put in your basement that pump water out and all that. But all right, so these both are low spots. They're locally the lowest spot. All right, so rain would collect there, I guess you could say. Is one of them the lowest spot? Yeah, that is a special name. These are both called local minimums, but this one is called the absolute minimum, as in it's the lowest of them all. On the other side of this, think about maximums. This one here is like the maximum, like the strongest one. Okay. So if this is the strongest kid in this neighborhood, could there be a stronger kid somewhere else in a different neighborhood? Yeah. It'd be like in this classroom, there could be a kid who's the strongest kid in this classroom, but not necessarily the strongest kid in the world. Okay? That would be the absolute maximum. So if we were going to test like who's the strongest kid in the room, maybe they could arm wrestle me to see if they're stronger than me. So who do you nominate to check and see if they're stronger than me? Liz? Here we go. Somebody's got to step up. All right, he's stepping up. Good job. All right. So, come on over here. Sit right there. The only catch is it's got to be left-handed.
Oh, I'm not left-handed.
Oh, exactly. Gives me a chance. All right, you ready? All right. Now, you can put your hand on the table if you want to. All right? Ready? Set, go. Oh, crap, he's short. He's got a big arm, but I'm going to beat him. Yeah. Oh, he's coming back. Oh, my arm is going to kill tomorrow. Oh. Oh. I thought I had him. I'm going to give up now. Oh. Dang, I had a chance. All right. So, yeah, he's pretty tough. Locally the maximum. Can you imagine if my forearm had broken right in the middle of that? Oh. I was twisting my wrist a little bit. That's cheating, but I got to do stuff because I'm an old guy. All right. So, he's the local maximum. At least he's beaten me, so. Now, that's okay. It's okay. I figured that was all right for people to hear. So, can there be more than one maximum? Yes, but in this case, there isn't. There's just that. That's a local maximum, and then there is no maximum. Do you get that? There is no absolute maximum because this graph goes up forever. So, moral of the story is, you can be two things at once. This is the local minimum and the absolute minimum. You can be both. It's like locally you're the strongest kid, and what if you're the strongest kid in the whole world? Then you're both. All right? Now, another little thing on my list of things to teach you was, let's see, domain and range, just one more quick review of that. So let's say we were looking at this picture, and I asked what the range was. The most common mistake is kids will say, oh, it goes from negative infinity to positive infinity. It kind of does, but it stops along the way. What's the one in range? We're talking about this way to this way. So what's the place where it stops along the way? 0. It'll never touch 0. So this range does go to negative infinity, and it does go to positive infinity, but there's one place along the way it never touches, which is right here. It never touches 0, so my range would be from negative infinity to 0, and it starts up again at 0 and goes to infinity. You get that? Okay. And the last part is about increasing and decreasing. So if I look at one of these graphs I had up here before here, do you agree that this graph is sometimes increasing and sometimes decreasing? Okay. So then if it's increasing, I need to be able to say where it's increasing. It increases this whole time. So that means it's increasing from negative infinity until I hit this spot. So let's say that that spot, those numbers are so nasty, I'm going to try a different one. So let's say it's right there at 5, 0. That'll be 0, 5. 0, 5. And let's say this is at like 3, -2. Okay, it's increasing along here. So it's increasing from, and here's the common mistake people make. They say it goes from negative infinity until 5. And I know some of you are thinking, wait a minute, that's right. No, it's not. It increases between negative infinity and 0. What it means is from at right here, it stops increasing. Okay? So like it's going from way over here at infinity, negative infinity, to right here at 0. So when you're talking about these, you're talking about the x numbers. Maybe this next example will make more sense to you. Where is it decreasing? It's only decreasing in one spot, from here to here. So is it from 0 to 3, or is it from 5 to -2? From 0 to 3. 0 to 3. And now you could even argue about whether to use parentheses or brackets, so I'll let you use both. But I personally would use parentheses, and here's my argument. That as soon as it hits 3, couldn't I make the argument that it's not decreasing anymore when it hits 3? Now, some people argue that it should be a bracket. In fact, I've seen some math books that use brackets because they say right up until that, it was decreasing until it hit the 3, including the 3. But again, you could argue it's all except either, but I prefer parentheses. All right, so that's where it's decreasing. How about where is it increasing from here to what? To infinity. And it's not up infinity, it's that way infinity. Okay, so it's from 3 to infinity that it's also increasing. Okay? All right. So now we have a little bit of homework to do, and I'll get you started on it. You'll need your calculators. There's a big part of this you're going to want to graph. That's usually the situation. I would say we use our calculator on about 2/3 of the test. Yep, about 1/3 of your tests you won't have calculators. That's just an estimate, but all right. I have a rule for myself that I don't want to hand out homework that just seems like there's no way they can get all of this done tonight with other things in their lives, because I know you have other things in your lives. Some of you have like cowboy mounted horseback shooting to do, you know, or maybe it's Wednesday, it's church night or whatever. So we're going to skip a few on here. Would you find 6, 8, 10, and 12? I'm going to allow you to skip those for now. And your homework tonight, just do every other problem except 6, 8, 10, and 12. I think that cuts it down to be a little more reasonable. All right, let's do number 1 together. Number 1 says, state whether each labeled point identifies a local minimum, a local maximum, or neither. Identify intervals on which the function is increasing and decreasing. This is a very easy question. It may seem painful, complicated, but it's not. All right, so I need to write down these points because they're kind of important. You've got them already, but All right, so now, local minimum, you can just go like this. Min, max, max. That's good enough. That's reasonable. Okay. And then identify intervals on which the function is increasing and decreasing. This one, you can't just write on the graph. You got to go off to the side and say inc for increasing, right? It's increasing from where to where? Well, it starts way over here, increasing until you get to there. Be careful. Which did I say it was, the x's or the y's? It's increasing from negative infinity until you get to where? Till negative 1. Yep. And then it's also increasing from 2 to 5. Yep. And then is there any other places where it's increasing? No. Next we do decreasing. Dec. And it's decreasing from here to here. And that's, remember, it's the x numbers of it. So negative 1 to 2. And then it's also decreasing from 5 to infinity. From here, forever that way. Okay? That's how you do that kind. Now let's skip down to number 5, as in the one right after 4. Number 5. F of x is absolute value of x plus 2 minus 1. Now you're going to use a graphing calculator, but I'm just going to do this rough sketch-wise. I know it's a V shape, and I know it's a V shape that's been moved. That plus 2 means left 2, and that minus 1 means down 1. So it's kind of going to look like that. Now what does it want? It wants the intervals on which the function is increasing, decreasing, or constant. All right. You don't have to use a graphing calculator for this one, because this is pretty easy. Do you agree you could figure out what this point is really pretty easy just by knowing how far left and how far down you went? So do you get, I went 2 spots to the left, so this is at negative 2, comma, negative 1. Okay, so now, where is it increasing and decreasing? Okay, increasing between what and infinity? Yep, from there over, it's increasing, which is from negative 2 to infinity. It's decreasing from way over here somewhere up until negative 2. So what do I say? Yep, negative infinity to negative 2. Okay. Now some of these you're gonna have to use that deal where it's got a curve in it. You know, you're gonna have to like look at it really close to see where is that point, and you'll have to use minimum and maximum on your calculator to figure it out. So let's say you graph it and it looks like this, and you're like, okay, well, how do I know what this point is? You can use that thing called maximum, and it'll tell you what that point is. And that thing I showed you on the calculator called minimum, it would tell you this spot right there. And let's say it says it's at 3, 2. Well, and I know that it increased, or and let's say this is at 0, 4. Well, and I know it increases or decreases between 0 and 3. Would be the decreasing part. So you might need to find these points using maximum and minimum on your calculator. All right. And then on the back side, it says number 14, without a calculator, get the range of that. That's what I just did a second ago. In other words, sketch it in your mind. It says this is number 14. F of x is negative 2 in front, and then x plus 4, plus 3, and then minus 4. I know that's a V shape that's been flipped up, down. It's been flipped up, down, and it's twice as tall, so it's been stretched up. So here's flipped and stretched. And then it's been moved 3 to the left and up 4. So generally it looks kind of like that. And you have to do it yourself, but oh, you're right, it's down 4, not up 4, sorry. Down 4. And the negative makes it flip. It's okay. And the 2 makes it stretch twice as high. So it stretches like this kind of stretch. It's like you grab this thing if it's made out of rubber, and you pull on it, and it becomes this. Okay. And now, don't forget to do the review. I noticed some of you did that on last night's homework. Some of you skipped the review problems. Don't do that. Oh, is there none on this? Okay. When there is review, make sure you do them. Okay, yes. Do 7? Read me 7. Minus what? Okay. Like that. Okay. I have no idea what this looks like. But with a calculator, you type it in. Can you describe to me what it looks like? All right, I'm just going to type it in quick. Absolute value of. So I go, I'm going to do it under catalog. Absolute value of x plus 2, x plus 2, and the absolute values. Oh, rats. Back to that. Get out of the absolute values. Then say plus. Then another absolute value of x minus 1. X minus 1. And the absolute value out of those. Okay, and then minus 2. Minus 2. Okay, I hit graph. All right. Now, this is a graph where it's got a flat spot in it. That's not increasing or decreasing. What's that called? Constant. Okay. So then I kind of need to know where those little spots are that are the important spots. So I'm going to zoom in on this. I'm going to zoom. In fact, I'm going to zoom box. I'm going to box in the area I want to see. And I want to see from there. I'm going to box in around that. And I'm going to see what that looks like. Aha! Okay. So I can see it's decreasing until it hits that one spot. Well, you can use trace. Can you see that that spot's pretty much -2? As soon as I went around the corner, it was -1.99. Okay. And then the y is 1. And then I can see where the other spot is that's kind of important. It appears to be 1, 1, but I'll see. .98. Oh yeah, that's got to be 1. 1, comma 1. Okay, so those are my 2 important spots on that. And then it increases from there. So from 1 to infinity. Okay? All right. And I think that's all we have for today.